Adding SSL certificates in AWS, GCP, and Azure generally involves provisioning an SSL/TLS certificate and attaching it to your load balancer or web service. Here's a step-by-step breakdown for each cloud provider. AWS, Amazon Web Services. Option 1. Using AWS Certificate Manager, ACM, with Load Balancer. On. Go to ACM Console, https://console.aws.amazon.com/acm. 2. Request a public certificate. Click Request a public certificate. Enter your domain name, for example, example.com, choose DNS or email validation. Complete validation, usually DNS via Route 53, is easiest. 3. Attach to Load Balancer, ALB/ELB. Go to EC2 Load Balancers. Choose your load balancer. Edit the listener for HTTPS, port 443. Select the certificate from ACM4. Ensure Security Group allows port 443. Option 2. Using CloudFront. Use ACM certificate in US East 1 region. Mandatory attach it when configuring CloudFront distributions. GCP, Google Cloud Platform. Option 1. Using Google Managed SSL with Load Balancer. 1. Reserve a static IP, optional but recommended. 2. Create a Google Managed SSL certificate. Go to Network Services Certificates. Click Create Certificate. Choose Google Managed. Enter your domain name. 3. Create/update a load balancer. Backend. Set up a backend service, for example, GCE, GKE, Cloud Run Frontend. Add a frontend HTTPS configuration. Attach the Google Managed SSL certificate. 4. Update DNS records. Point your domain to the load balancer's IP. Option 2. Using Let's Encrypt plus Cloud Run or GKE, use Certbot or AutoCert libraries. Integrate with a reverse proxy like Nginx or Traefik. Azure. Option 1. App Service, Web Apps. 1. Buy or upload an SSL certificate. Go to your app service TLS/SSL settings. Upload a PFX certificate with password or use Azure Managed Certs for subdomains. 2. Bind certificate to custom domain. Under Custom Domains, add your domain. Then bind it to HTTPS and select the uploaded cert. Option 2. Azure Application Gateway. 1. Provision Application Gateway. 2. Upload certificate. Use a PFX certificate. Upload it when configuring the HTTPS listener. 3. Configure listener and rules. HTTPS listener, use the uploaded cert. Set routing rules to backend pool, for example, VMs, app services. Tips for all platforms. Free SSL. Use Let's Encrypt if you're running your own web server, for example, Nginx, Apache Auto Renewal. Use Managed Certs or automate renewal with Certbot for Let's Encrypt. Redirect HTTP to HTTPS. Ensure proper redirection via server config or load balancer rules. You can add SSL certificates using Terraform on AWS, GCP, and Azure. Terraform provides providers and resources for managing SSL/TLS certificates and attaching them to services like load balancers or web apps. WAF. Using WAF, Web Application Firewall, in AWS, GCP, and Azure, helps protect your applications from common web exploits like SQL injection, XSS, or bot traffic. Here's how to use WAF in each platform. AWS WAF, Web Application Firewall, step by step. 1. Create a Web ACL, access control list. 2. Go to AWS Console WAF and Shield Web ACLs. Create Web ACL. Choose CloudFront, ALB, or API Gateway as the resource. Select the region and name your Web ACL. 3. Add rules, managed or custom. AWS Managed Rules, for example, AWS OS Managed Rules. Common rule sets, custom rules, IP set, regex, geomatch, rate-based rules, etc. 4. Associate Web ACL with resource. Choose your CloudFront distribution, ALB, or API Gateway from the list. Pot 5. Monitor requests. Use AWS WAF logs in CloudWatch or Kinesis. Terraform, example. Use resource AWS _WAF2 _web ACL, default _action, override _action and rules. GCP Cloud Armor, WAF for Google Cloud, step by step. 1. Go to Cloud Armor. 2. Security Cloud Armor security policies. 3. Create a security policy. Choose default allow or default deny. Add rules. A. Pre-configured rules, OWASP. B. Rate limiting. C. Geomatch, IP allow/deny. 4. Attach policy to load balancer. A. Go to your load balancer. B. Under security, attach the Armor policy. 5. Enable logging, optional, Terraform, example. Use resource Google _compute _security policy and rule. Azure WAF. Azure WAF is used with Application Gateway. Azure Front Door. Azure CDN, Microsoft. Step by step. 1. Choose WAF-enabled resource. Create or modify an app gateway or front door. Enable WAF, detection or prevention mode 2. Choose a rule set. OWASP 3.2 or 3.1. Add custom rules, IP, geo, size, rate limit 3. Associate the WAF policy. Link the WAF policy to the front end of app gateway or front door. 4. Monitor logs. Use Azure Monitor or Log Analytics. Terraform, example. Use resource AzureArm _web application firewall policy, custom rules and managed rules. DevOps in the cloud. DevOps in the cloud, a narrative across AWS, GCP, and Azure. Imagine you're leading a software team building a web application. You want rapid delivery, reliable infrastructure, automated testing, and zero downtime deployment. That's where DevOps in the cloud comes in. Each cloud provider offers a rich toolkit to help you go from idea to production in a fast, safe, and repeatable way. AWS DevOps, the automation giant. In AWS, your DevOps journey begins with AWS Code Commit, a Git-based repository where your team stores code. Every commit automatically triggers AWS Code Pipeline, which chains together your C/CD stages, testing in code build, deployment using code deploy, and even approval workflows. For hosting, you might use Elastic Beanstalk, ECS, or EKS, Kubernetes. You can define your infrastructure using CloudFormation or Terraform, allowing you to spin up new environments with a single command. When your app goes live, Amazon CloudWatch gives you dashboards, metrics, and alerts, while X-Ray traces how requests flow through your system. Secrets like API keys are stored securely in Secrets Manager or SSM Parameter Store, keeping them out of your code. With AWS, everything integrates tightly, and it's built to scale with massive automation, high availability, and strong security baked in. GCP DevOps, the Kubernetes native innovator. In Google Cloud, your pipeline starts with cloud source repositories or GitHub, and connects to Cloud Build, which builds and tests your Docker images in a fully managed environment. These images are stored in Artifact Registry, ready for deployment. Enter Cloud Deploy, a modern delivery tool that supports advanced release strategies like canary rollouts and progressive delivery. For runtime, GCP excels with GKE, Google Kubernetes Engine, a production-grade Kubernetes service backed by Google's deep expertise. You can also deploy to Cloud Run for serverless containers or Cloud Functions for event-driven logic. Cloud Monitoring and Cloud Logging, formerly Stackdriver, give you observability, and CloudTrace helps analyze slow requests. Configuration and secrets, handled by Secret Manager and Config Connector. GCP's DevOps stack is especially attractive for teams using Kubernetes, emphasizing open-source tools, fast build times, and deep DevSecOps integration. Azure DevOps, the integrated enterprise powerhouse. In Azure, DevOps is often synonymous with Azure DevOps Services, a full suite including repos, boards, pipelines, artifacts, and test plans. This all-in-one platform lets teams manage planning, coding, building, testing, and deploying without leaving the ecosystem. You start with Azure Repos or GitHub for your code, then build and deploy using Azure Pipelines. Pipelines support multi-stage YAML workflows and can deploy to any cloud, not just Azure. For hosting, you can choose Azure Kubernetes Service, AKS, App Service, or Azure Functions. Infrastructure is managed using ARM templates, Bicep, or Terraform. As your app runs, Azure Monitor and Application Insights track performance, while Log Analytics enables deep queries. Secrets go into Azure Key Vault, accessible only via secure role-based permissions. Azure's DevOps experience shines for enterprises already using Microsoft products, with seamless integration into Active Directory, Teams, Office 365, and GitHub. A short and technical overview of disaster recovery, DR, strategies in AWS, GCP, and Azure. AWS Disaster Recovery. Key tools. S3 Cross-Region Replication. RDS Multi-AAS and Cross-Region Read Replicas. Route 53 for DNS Failover. Cloud Endure or AWS Elastic Disaster Recovery, DRS EC2 AMIs and snapshots for backup. Docker strategies. Backup and restore, S3/Glacier, snapshots. Pilot Lite, minimal resources running, DB, AMIs for app servers. Warm Standby, scaled down full stack in secondary region. Multi-site active, fully redundant setup across regions. GCP Disaster Recovery. Key tools. Cloud Storage Dual/Multi-Regional Buckets. Cloud SQL Cross-Region Read Replicas. Cloud DNS with failover policies. Velastrada or third-party tools for VM migration. Snapshots and machine images. Docker strategies. Backup and restore, cloud storage plus snapshots. Active-passive, use cloud load balancing plus managed instance groups. Cold/hot standby, deploy via deployment manager/Terraform in another region. Multi-region architecture for GKE, Spanner, Bigtable. Azure Disaster Recovery. Key tools. Azure Site Recovery, ASR, primary Docker tool. Geo-redundant storage, GRS Azure Backup, VM Level, SQL, SAP Traffic Manager, Front Door, DNS-based failover. Availability zones and regions. Docker strategies. Backup and restore, Azure Backup plus GRS. ASR-based replication, replicate VMs between regions. Zone/region failover, deploy apps across availability zones or paired regions. Active-active or active-passive, via load balancer or front door.